Okay, guys, welcome back to our channel. In today's slide, I want to walk us through on how we can balance chemical equation using algebraic method. We have several ways of balancing chemical equation. The first one we have the inspection method. We have the inspection method. So the second way we have the algebraic method, and the third one we have half reaction method. This particular half reaction method is mostly used for redox reaction. If you look at this reaction, this is not a redox reaction. So we're going to go with this algebraic method. So the inspection method is the most common way of balancing chemical equation. So let's start the most systematic way, the algebraic method. Okay. So let's look at this. I want to walk us through one of the simplest steps in algebraic method. The first thing you're going to do is to assign unknown coefficients to this variable, to these solids, reactants and products. So I'll come here, I'll say, I'll call this A, I'll call this B, I'll call this C, and I'll call this D. Remember that whenever you want to balance chemical equation, all you just need to do is to actually put the right coefficient in front of each of the molecular machine. So we do not know what the coefficients are, and as a result of that, we're actually replacing it with an unknown coefficient, which we are going to solve for afterwards. Now, the next thing we are going to do, the first step is to assign unknown coefficients, which we've already done. The next step is for us to write a balanced chemical equation for each of the elements. Now, how many types of elements can be found here? Now, let's check it out. Potassium is K, carbon, oxygen, aluminum, and chlorine. We have 5 elements present in this compound. Okay? Now, this is what we are going to do. We're going to write a balanced chemical equation for each of these elements. Now, let's start with the first one, potassium. Now look at the left-hand side. Potassium is 2 here. The atonicity of potassium is 2. But you have to multiply this 2 with this A. 2 times A is 2A. There is no potassium here. This is equals to, you come to the right-hand side. There is potassium here. 1. 1 times D is D. I've actually succeeded in writing the balanced equation for in terms of potassium. So let's look at that of carbon. Carbon is 1 here. 1 times A is A. There is no carbon here, so I move down to equals to. There is carbon inside the bracket. 1 times 3 is 3, 3 times C is 3C. Okay? Now move down to oxygen. We have oxygen is 3 here. 3 times A is 3A. There is no oxygen here, move down to the product. You can see there is 3 oxygen inside the bracket. 3 times the 1 outside, that's 9. 9 times C is 9C. Okay, now we move down to aluminum. Aluminum is 2 here. 2 times B is 2B. Now here, 2 times C is 2C. Now for that for chlorine, chlorine is 6 times B, 6B. Chlorine here is 1. 1 times D, D. This is equation 1. This is 2. This is 3. This is 4. And this is 5. Plus, the next thing you're going to do, the rule number 3 says, choose one of these coefficients and give it a value of 1. Any one of the coefficients. Alright? But myself, I'm actually going to give B the value of 1. I'm actually going to give B the value of 1. So I'll say, let's B equals to 1. Remember, there is no one that said it was the B. Any of these unknowns, you can give it to A, you can give it to D, you can give it to C. But make sure you choose the one that will help you to get other ones easily. For this particular guy, I'll choose B. So I'll say let B equals to 1. So I come to equation 5. I'll take from equation 5. Anywhere I see B, I substitute the value of 1. So this becomes 6B equals to D. Now this is 6 equals to D. So therefore, we've gotten our D to be equals to 6. Very simple. Now look to this equation again. From equation 1, there is D here. So if I put D here, I'll be able to get my A. So I'll say from equation 1, 2A equals to D. Remember, we've gotten our D to be 6. So this becomes 2A equals to 6. My A becomes 6 over 2. That is 3. Okay. So we've gotten our B to be equals to 1, we've gotten our A to be 3, we've gotten our D to be 6. Now what we have next is for us to get our A and our C. So on to equation 2. Now look at this equation 2 here. I've gotten A, there's A here. So if I put A, that will be able to get my C. So I'll say A equals to 3C. So anywhere I see my A, I put 3 equals to 3C. So therefore, C equals to 3 over 3, that is equals to 1. Now, what is left for us to get? We've gotten all the variables, all the unknowns. Our A is equals to 3. Our B is equals to 1. Our C is equals to 1. And our D is equals to 6. We've gotten the coefficient for that. So let's move ahead to substitute all of this into this. So I'll come here. I'll say, anywhere I see A, I'll put 3. Anywhere I see B, I'll put 1, but I'm not going to write the 1. Anywhere I see C, I'll put 1, but I'm not going to write the 1. And anywhere I see B, I'll put 6. And then we go a balanced chemical equation. Potassium, let's check it out so that you realize that the equations are all balanced. So we have our potassium, 2 times 3 is 6. This is 3 times 2 is 6 equals to, on the right hand side, we have 6. So potassium is balanced. So we have 6 on the left, 6 on the right, potassium is balanced. Carbon, 1 times 3 is 3 on the left. Carbon is 1 times 3, 3 on the right. Carbon is balanced. Oxygen, 3 times 3 is 9. Equals to 3 times 3 is 9. Oxygen is balanced. Aluminum is 2 here. 2 on the left. Aluminum is 2 here. 2 on the right is balanced. Chlorine is 6 on the left. 6 on the right is balanced. So therefore you have a well-balanced chemical equation. Thank you very much. Okay, now, so we have this other question here for us to solve. In the previous video, if you actually just look at view this video for the first time, you can actually check our previous video on how we explain balancing of equation using algebraic item. So step number 1 is for us to assign unknown coefficients. So I put A here, I put B here, I put C here, and I put D. Now step number 2 is for us to write a balanced chemical equation in terms of each of these elements. Now how many elements do we have here? Now let's look at it out. We have sodium, we have phosphorus, we have oxygen, we have magnesium, and we have chlorine once again. Now look at this. How many sodium can you see here? This is 3. 3 times A is 3A. There is no sodium here. And move down to the product side. How many sodium can we find here? 1. 1 times C is C. Now how many phosphorus can you see here? Is 1. 1 times A is A. Now this is equals to, now phosphorus here, you can see phosphorus is 1 inside the bracket. Now this is affecting this phosphorus. So this becomes 2 times D. So phosphorus is 2D. Oxygen is 4. 4 times A is 4A. There is no oxygen here, so we'll move that to the product side. You can see oxygen is 4 times 2 here, that is 8. 8 times D, that is 8D. Now, magnesium is actually 1B equals to here, we have 3D. Chlorine is 2 here, 2 times 3 is 2B. This is equals to 1 times C is C. So this is equation 1, this is equation 2, this is equation 3, this is equation 4, and this is equation 5. So you can take a look at this. Now, the next thing we are going to do is to look for one of the coefficients here to assign a value of 1. Remember, any of the coefficients can be assigned a value of 1, any one of them, right? Now, let's actually see which one I'm going to make use of here. So I'll actually give, I'll say, let D equals to 1. I choose to give it to D. You can choose to give it to A or any one of them, but personally, since my name is Gelzi, I choose to start with D. Alright, so we'll come here. So we'll say, anywhere from equation 2, anywhere I see D, I'll put 1. So this is A equals to 2D. So this is A equals to 2 times 1, which is 2. So therefore, A equals to 2. Now, I'm putting my A, so therefore I can get my C from equation 1. I'll say from equation 1, 3A equals to C. Anywhere I see A, I put 2. So this becomes 3 into 2 equals to C. So therefore, C equals to 6. I'm putting my B to equals to 2. I'm putting my D. I'm putting my C. What is left for me to get is now my B. So I'll come here and say, move down to equation 4. Perhaps we can use equation 5. But I want to use equation 4 because I already have a value for D. So I'll say from equation 4, B equals to 3D. Anywhere I see D, I put a value of 1. Now, what is the value of D? 1. So this equals to 3 into 1. So this is equals to 3. So therefore, my A is equals to 2. My B is equals to 3. My C is equals to 6. And my D is equals to 1. I can now come back here and substitute the entire value. So let's see what we are going to have. So anywhere I see my A, I'll put a value of 2. Anywhere I see my B, I'll put a value of 3. Anywhere I see my C, I put a value of 6. And anywhere I see my D, I put a value of 1. The equation is balanced. Let's check it out. Sodium, 2 times 0 is 6 on the left hand side. Sodium is 6 on the right hand side. Sodium is balanced. Phosphorus, 2 on the left hand side. 1 times 2 is 2. On the right hand side, 1 times 2 is 2. Phosphorus is balanced. Oxygen, 4 times 2 is 8. We come here, 4 times 2 is 8. Oxygen is balanced. Now, magnesium, 3 times 1. 1 times 2 is 3. Equals to magnesium is 3. Magnesium is balanced. Chlorine, 2 times 2 is 6. Chlorine is 6. The equation is balanced. So you can see with algebraic method, you can balance any equation of your choice. Please drop a comment on the comment section to actually tell us what you think about this method. Thank you.